Hello viewers, this is Dr. Fathima welcoming you to the session on data structure. Hope you have watched my previous videos on singly linked list and doubly linked list. In this video, let us see about circularly linked list, the operations on circularly linked list like insertion, deletion and search. First, let us see what is circularly linked list. It is a type of linked list with a slight variation. Hence, both singly linked list and doubly linked list can be made into a circularly linked list. What is singly linked circular list? It is similar to singly linked list except that the next pointer of last node is made to point to the first node. In the example shown, you can observe that the next pointer of the last node, that is the tail node, is made to point to the head node, thus making it circular list. What is doubly linked circular list? It is similar to doubly linked list except that the next pointer of last node is made to point to the first node and the previous pointer of the first node is made to point to the last node. In the example shown, you can observe that the next pointer of the tail node is made to point to the head node and the previous pointer of the head node is made to point to the tail node, thus making it a circular list. Next, let us see the operation on circularly linked list. The insertion operation, which can be done at the beginning, at the middle or at the end. The deletion operation, which can be done either at the beginning, at the middle or at the end. And then the search operation to search whether the element is present in the list or not. Let us see the operation of insertion in detail. When we do the insertion in the beginning of the list, there are two possibilities that it can be either done in the empty list or in an existing list. Let us see the first case of insertion in the empty list. The first step in the insertion is creation of the new node and set the respective fields. The instruction shown does it through declaration, memory allocation through a malloc function, then set the data and the next field of the new node. Thus, the new node is created as shown. Let us assume the new node n is created at the address 2048. As there are no other node in the list, set the head and the tail pointer to point to this new node n. These steps are similar to the step carried over in singly linked list. The step which differs is making the next pointer of this new node n to point to itself, that is head, thus making it a circular list. Then the insertion is completed. Next, let us see the second case, the insertion in an existing list. Consider the example shown. As usual, the first step is the creation of new node and set the respective fields. To insert, we make use of the temporary pointer P to initially pointing to the head node. Traverse the pointer P by progressing P to the next node by setting P equal to P dot next. This is done until we reach the node whose next pointer is pointing to the head node. Now set the next pointer of P to point to the new node n by setting P dot next is equal to n. You can observe the change in the next field of the tail node, which is replaced with the address of the new node, that is 2048. Then the next pointer of the new node is made to point to the head node by setting n dot next is equal to head. You can observe in the example shown that the null value in the next field of a new node n is replaced with the address of the head node, that is 1007. Finally, set the new head to point to n, as this is the new node inserted in the beginning of the list. Thus, the whole head disconnects and the insertion is completed. Next, let us see how insertion of the node is done in the end of the circular list. The first step of insertion is the creation of new node and setting the fields. This is done as usual. Thus, a new node is created. To insert in the end, we make use of a temporary pointer P, which is made to point to the head node initially. The pointer P is made to traverse through the list until it reaches the last node. In the singly linked list, the last node is identified as the node whose next pointer is null. But in singly linked circular list, the last node is identified as the node whose next pointer is pointing to head. Then set the next pointer of P to point to the new node N. Observe the changes in the example shown that the next field of P is replaced with the address of the new node, that is 2048. Then set the next pointer of the new node N to point to the head node by setting N.next is equal to head. Thus making a circular list. You can notice that the null value in the next field of N is replaced with the 1656, which is the address of the head node. The link between P and head node is disconnected. Thus, the insertion in the end is completed. Let us see the insertion in the middle of the list. When insertion is done in the middle, we are supposed to know that after which node the insertion to be carried out. The first step of insertion is creating the new node and setting the appropriate field. This is done as usual. When we are performing the insertion in the middle operation, we are not disturbing either the first node or the last node. Hence, there is no difference in the steps of insertion. It is similar to that of the singly linked list. Initially, the pointer P is pointing to the head. Progress the pointer P until the node after which insertion is to be carried out. Once the node reached, then make the next pointer of N to point to the node where P.next was pointing. Watch the change. Then make the next pointer of P to point to N. Observe the change in the address field of P. Thus, the insertion is completed. Next, let us see the logic of deletion of the node at the beginning of the list. As the head node is deleted, we have to set new head. We make use of two pointers P and P1 to point to head node initially. Make the pointer P to traverse through the list until it reaches the last node. Because as the first node is deleted, the next pointer of the last node has to be changed. This is done by setting the P.next is equal to head.next. Observe the change in the address field. And the link between P and head node is disconnected. Then set the node where P.next is pointing as the head node, thus making it a circular list. This is where the logic differs from that of the which we have seen in the singly linked list. To delete the node physically, free the node pointed by P1. As the pointer P is traversing through the list, the head pointer and the head pointer is also changed. We need a reference to point to the head node. That's why we made use of the extra pointer P1 to point to the head node initially. And free of P1 is done. Thus, the deletion of done. Next, let us see how the deletion of the node at the end of the list is performed. Here we make use of two pointers P and Q. P is made to point to head node initially and Q is made to point to the node succeeding P. Both the pointer P and Q are progressed until Q reaches the last node. Once the last node is reached, the pointer P which is preceding Q is made to point to the head by setting P.next is equal to head, thus making it a circular list. The link between the Q and the head node is disconnected. This is where the logic differs from that which we have seen in the singly linked list. To delete the node physically, make use of the instruction free of Q. Thus the deletion is completed. Next, let us see the deletion of the node in the middle of the list. Assume let n is equal to 70 be the node to be deleted. As we are not disturbing the first node or the last node during the deletion process, the logic is similar to that which we have seen in the singly linked list. We make use of two temporary pointers P and Q, where P is pointing to a head node initially and Q is pointing to the node succeeding P. The two pointers P and Q are made to traverse through the list until we find the node whose data to be deleted. Once the node that is reached, here which is pointed by Q, then make the next field of P to point to the node which is pointed by Q.next. Observe the link established and the old link disconnected. The node Q is free to delete it physically. Thus, the deletion is completed. Next, let us see the search operation. The procedure is similar to that of the procedure followed in the singly linked list. Let us assume n is equal to 70 be the data to be deleted. Make use of a temporary pointer P to point to head node initially. Make the pointer P to traverse through the list until the data given is found or end of the list is reached. This is done by progressing P to P.next. This is where the procedure differs. Here P.next is checked for whether it is pointing to head or not to identify the end of the list, instead of P.next checked for null in the singly linked list. Hence, when the data found or last node reached, the traversal stops and checked for the data found condition. If true, then print data found, else print data not found. Hence the search is done. Hope the video was informative. See you in the next video. Have a happy learning.